All right, so here's our last trig video. A few things just to remember before we jump into this so that you remember where things come from. The radius of the unit circle is 1. Cosine is my x value. Sine is my y value. And tangent is a slope function or a rate of change function, so it is sine over cosine. So we're going to be using those. There's really only one new thing that we need to add today, and it has to do with this picture right here. So remember, this comes from the radius being 1. That's where that comes from. Cosine is x, and sine is y, and that creates a right triangle. And if we think about right triangles, hopefully somewhere in your brain, you pull out Pythagorean theorem. And remember, Pythagorean theorem is a squared plus b squared equals c squared. So where c is the hypotenuse. So in this case, we get cosine squared plus sine squared equals 1. Because that's a squared plus b squared, the two hypotenuse equals c squared. And that c squared that's really like 1 squared, but 1 squared is just 1. So at this point, if I were taking notes, I would have all of these three things written down, and I would probably have this written down as well. Now, the only other thing that I want you to maybe add to that, and I'll zoom in on this so that we can see it. This is just how to solve each of those for sine and cosine. And you don't have to do this, it's just a shortcut. So notice they're starting here. And for each of these, they're just solving for the individual value. So to get sine by itself, they've subtracted cosine over. And then this is sine squared. And you want to undo the squares. So to undo that, remember the inverse of squared is square root. Sorry if you're hearing my kid's toy in the background. And then they do plus or minus because remember when you take the square root, you get two answers, a positive and a negative. The same thing happens with cosine. So if you want to add something extra, these are just rewritten versions of this original equation are these two things themselves. But you don't have to add those. They are all kind of inherent in that first Pythagorean identity that I showed you. All right, so let me show you some examples. Okay, so a few things to start off with. Notice that they're telling me about sine. They're asking me to find cosine, which is going to tell me that I'm going to use sine squared plus cosine squared equals 1 as my starting place. This right here just tells you what quadrant you're in. So if you think about your, using this, if you think about your little like unit circle, pi over 3 is down here, pi is right there. So we're talking about this third quadrant, which is negative, negative. Cosine is so I'm going to make two comments. Cosine is your x value. So I'm trying to find the x value here. And in this instance, the x value is negative. So that means my final answer is going to be negative. That's the only reason that they tell you about this quadrant right here, is to help you figure out if you should be getting a positive or a negative answer. All right, then we're just going to start plugging our values in. So I'm going to use this original formula. So I'm going to put in 0.644 squared, negative. The whole thing is going to get squared, so I'm putting the squared on the outside, plus cosine squared equals 1. All right, that gave me 0.415 plus cosine squared. All right, so I'm going to subtract this over to the other side, which is going to leave me with cosine squared equals 0.585. And now all I have left to do is undo the squared, so I'm going to square root. That's going to tell me that cosine, whatever this angle is plus or minus 0.765. Now, I want to know, or in this problem, I've already told myself that cosine is the x value, and it should be negative, right? Because the x value here is negative. So my final answer here, just to be clear, is that cosine is negative 0.765. All right, on this one, I'm going to show you how to use that alternate formula. So instead of starting all the way from sine squared plus cosine squared equals 1, I'm going to do the square root formula. So This is the formula that I'm talking about. Sine equals, this has just already been rearranged. Sine equals plus or minus the square root of 1 minus cosine squared. Now I am going to go ahead and make some notes for myself, just like we did on the last one. This right here, that means that we are pi over 2 and pi, so we're in this second quadrant over here. In this second quadrant, the signs are negative, positive. Well, I want sine, which is my y value, so that means I need a positive y value. I'm going to highlight so you see what I'm doing. Sine is y, and in this quadrant, y is positive, so my final answer should be positive. If you're taking ACT or an EOC, this process of positive negative would just help you to eliminate your answers right away. So I'm going to show you kind of what they did already worked out. All right, so all they've done here is they've plugged in the value for cosine. You can see they just took this value and plugged it into this reworked formula. And then using a calculator, they've just typed the square root in. And we know, we just found out that the answer should be positive, so this is exactly what this says. The answer here should be positive. That's my final answer for sine. Now the rest of this question asks me to then find tangent. So let me just remind you how to do that. We said that tangent equals sine over cosine, because tangent is a rate. So I know sine is this 0.109. Cosine is negative 0.994. I'm getting that from this original problem, so I'm just pulling these two things together here. And that should give me 0.10, well, I guess it's 1096, so 0.110. So tangent of theta here equals negative 0.110. It's negative because it's positive divided by negative there. All right, so that's how you do those. This is the last type of problem. If you want to write this example down, you can, but this takes a little more talking through that we're probably going to do in class tomorrow if we need to. We'll just see where we are.